there's several errors I made with the previous chapter, the way I was doing things. One of the biggest problems is getting your mind to engage with the matter, with the text. You've got to find your speed and try your best to think about whatever you are reading and make it your own. That's why at some stage I said I was going too slow, I should go faster, which is actually a mistake. The actual problem was my mind wasn't engaging. I sensed that because I was reading too much and writing too much. So you should pause and think about what you're reading, contemplate it, especially when you're doing something, this way, I think, summarizing. Then you should think more. Read less, think more. Sorry. That's one of the mistakes I made. The other mistake I made is the chapter heading and the section headings. That should guide you. You should really be on the lookout for that terminology in the text and know you're supposed to read. If you see that, if I see something, if I catch the word waves in the text, I should really know this little part is important. I have to give more attention to it. The other thing I realized is the name of Max Planck came up frequently, and that should have been indicated to me again that if you see that name in the text, scan around it, see what you can pick up about that. So I think those are the three things that's important that you should keep in mind when you read. Try and summarize it. So let's see how many pages I have. From 42 to 54. How much is that? That's a 2 and a 5 minus 4 is 12. I think it's 13 pages. So it's a little bit longer than the previous one. I think the previous one was 11 pages. I can't remember. But anyhow, I've got to watch the time so I don't go over. So the chapter heading is Matter Waves. So it's something about matter, which could be atoms, solids, liquids, gases, plasma, something about matter and waves. Matter is concentrated, waves is distributed, there's usually oscillations, frequency, wavelength, that concept, and something is oscillating. Is it a field? So what is the relationship between matter and waves? The previous chapter was about quantization. And now they're going back to waves. That is the thing in quantum physics. It seems that these two things keep coming on. Is it a matter? Is it a particle? Is it a wave? These things keep on coming up. I think there were two camps initially. One camp was, oh no, it's waves. Another camp was, no, it's particles. And then eventually, now we see we're stuck with the two, and the difficulty is deciding which way is the quantum physics going. So let's have a look at this. It's a model of the atom. So something about atoms and the constituents. There's Planck's name again. Model of the atom. Atomic mass. So it's about the internal structure of the atom, it seems. Coffee. Radioactive atoms. Yeah, so it's still on the topic of the structure. What is going on inside of the atom? Its constituents. Neutrons, protons, electrons. How's it structured? Empty atom. Size, it seems. So yeah, this little section is about the structure of the atoms. So the question is, how does waves come into the picture then? Momentum quantization. Bohr orbits and momentum quantization. Momentum, that we associate with a particle, mass, speed of the particle. It's got momentum. Momentum, impulse, one hits it, and it's momentum conservation. I think it's action reaction. So if you look at an isolated system, you've got conservation of momentum, I think. So my physics is quite rusty. So momentum is a movement. So these particles are in motion and they've got momentum. And the momentum is quantized. So as far as the atom is concerned, or the constituents of the atom, there's quantization going on. You can't get any value you like. Maybe that relates to the spectroscopic lines, the atomic lines. Something about charges. And now electrical forces. Newtons. Yeah, so acceleration, orbit, electrodynamic theory, emission of light, spectral lines. So what is happening here? Forces, electric forces, spectroscopic lines. So I'm getting the impression they're going it's trying to structure what is the structure of the atom so it can produce these spectroscopic lines. Electrons orbited, so it's Bohr's model of the atom. Some period, spectral lines. Yeah, so it's about the spectral lines. And there is the photon, emission of the photon. So the question is, how does momentum come into play in this story? Coffee. Mug is almost empty. One more sip. Rydberg's constant. So what can I make of all this? Atom, structure of the atom, emissions, spectral emission, and there's the quantum structure. talking about the electrons, is the energy levels of the atom. Here's something going on. Rydberg constant. And there are the spectral lines. So we are going towards matter and waves, and now they're talking about spectral lines. So, but as far as I remember, that waves is not this spectral lines, it's a different wave that's being discussed. What I remember of my physics: photons, electrons, atom, energy differences, quantization condition, wavelength, electron jumps. So it's the structure of the atom which they say produce these spectral lines, the internal structure of the atom. Photons, ionize, nebula and Orion, orbit shells, very time-wise. It's getting on. Electron, Niels Bohr. We're still with the spectral lines. Electrons in the same shell. Spectral line pattern. So spectral lines, atoms, electrons. Okay. Then electronic structure. Charged particles, electromagnetic mass. What? Electromagnetic mass. Maxwell's theory of electrodynamics. Mass of an electron. Electromagnetic field. So Maxwell's theory of electrodynamics. Charge, electrostatic repulsion. So what is this about? Electromagnetic field. So Maxwell, that's the EM waves, electromagnetic waves. So now we're going into waves, electronic structure, electromagnetic waves. These atomic emissions are electromagnetic waves, but now we've got quantization and waves. So I'm trying to put everything together, trying to keep it doesn't fragment. I'm trying to see how does all these pieces fit together. That's what I'm trying to do when I'm going through this mathematical analysis, special relativity, motion observer. Oh goodness. Electron structure, Pauli, oh goodness gracious, Compton radius of the electron, they go way out. Einstein's equation for high speed, oh god, electromagnetic, oh this is going wild. this page here is going wild. It's going in all directions. Simplest picture of the electron. Vanishing small particle. electromagnetic energy, point like atom, electrons, electrical currents, magnetic fields, spectral lines, so there you can get lost. Matter waves, finally we're at matter waves. What's the time wise? I'll have to stop sometime, it's getting on, it's going for, I'll just have to watch the time. Matter waves, production of light, contradictory pictures of reality, phenomena of light. So the struggling of light, wave particle duality. Okay, so that's the photon and the wave, so they're into light and the structure of the atom. Thesis, de Broglie. Wave mechanics. What waves? Ballot for all particles. Copper, Einstein, photons. Momentum of a particle. So is it the electron? Planck's energy. What energy is this of the wavelength? Energy, is that the emission? There's the formula, the matter wave formula. Wavelength, Planck's constant, and P is the momentum, I think. Yeah, momentum of the particle. There's the magical formula. So, momentum and wavelength. So what wavelength is this? The can't remember what we're talking about. Is that the matter wave? Matter wave-like properties. There it is. Matter had wave-like properties. That's the matter wave. So this wavelength is some wave that is associated with the matter. If it has that momentum, it has that wave associated with it. I think that's the story. Using de Broglie's matter wave formula. Ooh. So I stopped and started again. Just there's no interruption when the camcorder makes a new file. Okay, so we here with the a matter wave. The matter's got momentum, and then we get a wave associated with the matter. So what does that have to do with everything? De Broglie proposed that these waves were actually guiding matter to behave as wave-like objects, but were not themselves waves of matter. So it's a guiding wave. So there's some wave guiding the motion of the matter, it seems. Diffraction pattern, electron diffraction pattern, X-rays. Wave-like characteristics. Matter did in fact display wave-like characteristics. What does that mean? diffraction patterns, X-rays. So there's the waves behave as if there is matter behaves, or in this case electrons behaves as if there is a guiding wave, a wave guiding their motion. And that is dependent on their momentum, the momentum of the electrons. Quantized orbits in the atoms. Application of these waves. Quantized orbits. Quantized orbits in the atom. So it seems these associated waves are responsible for how the electrons are configured or positioned or motioning in the atom. How is they've got a certain momentum, and that determines the orbits. Integer number of wavelengths, circumference of the orbit. That's the story. So the wavelengths have to fit. So, and that determines the orbit. Electrons diffracted like light waves. So it's the electrons, orbits, matter waves, and these matter waves quantize determines the structure, the electron structure, or how the electrons are inside of the atom. And there's the quantization. And that's the chapter. Matter waves, structure of an electron, electron diffraction. So what would I say this, by skimming the chapter, what would I say is happening here? They associated some guiding matter wave with the electrons, and the wavelengths of the associated matter waves is determined by the momentum of the electron, and that quantizes the structure. You need integral amount of wavelengths to fit in the orbit. They will only position at those orbits, and that quantizes the structure, the electronic structure of the atom. Okay, got sort of an idea what this is about. Matter waves, atoms, electronic structure of the electronic orbits, momentum of the electrons. that's what this chapter is about. So next time I'll summarize it on my little pieces of notepaper.